Hello everyone and welcome to part 11 already of To Be Astronomer Reacts to Geocentric movie. Now, it has been almost a week since I recorded the last episode, so please forgive me if I've forgotten anything and if I wanted to say anything. I'm very sorry. We are only at half of that thing, so yeah, I'll probably skip something at the very end. Yeah, so let's continue.
You might say, if they exist for a time that's so short you can't even see them, it's like counting angels on the head of a pin. It's like philosophy, it's not like physics. But in fact, while we can't see those virtual particles directly, they do have an impact, an indirect impact on atoms and the structure of atoms in a way that we can actually predict.
So we know.
That's true. I'd encourage you to look up the Casimir effect for that. Which was really, or the Casimir experiment really, which was really kind of fundamental in understanding the way that this works, right? With the Casimir effect, you have two plates, and if you bring them close enough together, so close in fact that particles in between can no longer be created because you've very clearly defined their space, right? So you kind of force the uncertainty here. You would expect that on the outside particles would still pop in and out of existence, so the pressure outside should be a bit higher because there should be virtual particles kind of bumping into those plates, and that's exactly what they measured. That's very simplified, of course, but in general that's what happens. It's really interesting.
Now realize that nothingness is foamy, is foam created by subatomic particles darting in and out of existence. Well, if subatomic particles could do this,
some people have called this the quantum foam. Yeah, that's a name.
why not universes? We now believe that in the quantum foam, baby universes are constantly appearing.
Oh well, I mean that's really that's really his interpretation of what's going on. I don't agree with small universes. What does that even mean? That I disagree with that statement. That's very much what he calls those things, the way he would interpret all of these. So I don't think so.
So if I had a super microscope and could look down at the fabric, the instantaneous fabric of space-time itself, I would see a bubble bath with baby universes being formed all the time.
If you have nothingness.
Again, he calls them baby universes, really. The thing is that when you look kind of, if you were to zoom out as far as you can, based on our understanding of galaxies, right, you get what's called galactic filament structures, and I'm not talking about filaments within galaxies, which exist as well, but I'm talking that the galaxies itself kind of align and look a bit like a foam, if you will. There are areas where there's quite a lot of galaxies and a lot of galaxy groups, really, and then there's areas where there are very little, right? And this kind of resembles the structure you would expect within a foam, on a very large scale, and also on a very, 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 very small scale, the smallest of scales, actually, I believe.
Quantum fluctuations will always produce something. And when you add gravity in the mix, it's even possible that whole universes could come from nothing.
Big bangs.
Well, I mean, it's not nothing. It's physical kind of nothing, if you will. It's still something. Yes, they pop in and out of existence, and if you add gravity, you can get a certain idea of where things could come from, really. However, I'd like to say here that when it comes to what happened exactly at the Big Bang, as it's referred to, is very much cause of debate between scientists. It is the only honest answer is we don't know what happened right at the Big Bang, but we have a pretty good idea of what happened almost for practical purposes instantly after the Big Bang. A few microseconds or even lower. It's incredibly precise, really, like in incredibly small time frames after the Big Bang. We kind of are able to figure out what's going on.
This happen all the time, but most of them don't get anywhere. They pop back into the vacuum. But our universe was special. Our universe, for some reason, popped out of nothing and just kept on going.
So not only is all the evidence suggestive that we came
I mean, really, again, that's his kind of idea. Like there are many ideas about how this could have happened. This certainly, right? Seems like a reasonable, albeit ad hoc explanation, right? Um, but sure, if he, although I'd like to say very much, I'd like to emphasize that this is his belief, right? He says that he thinks that this is the most probable of the origin of our universe, and that's fine, right? That certainly is one of the ones that one could consider, really.
From nothing. But the laws of physics tell us that it's to be expected that something comes from nothing.
The laws of physics don't really make a claim about something coming from this hypothetical nothing that Lawrence Krauss mentions here. The way I see the physical laws don't make us expect it, but they don't explicitly forbid it. It is a possibility, right? And now I'm curious. If I remember correctly, he's not a physicist. Curious what he has to say about it.
Impose on the science, on their observations, they impose their worldview, which is really their religious belief system.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, to try to explain the data, such as inflation, dark matter, dark energy, and so on, just to keep patching the theory up.
It's not really patching the theory up. I mean, how do I say it? It's a consequence, really. The way he sees it as patching a theory up is more like incorporating observational data within the theory. So if he was true, if every time we incorporated some new effect into an already understood theory, then I don't know, explaining that very early on in optics. Was it patching up when they figured out that white light is made out of all of the colors of the rainbow? Is that also patching it up? No. So I don't really know what he's on about. He just wants to make these the things that modern physics has found out to be ridiculous, most likely, and well, probably because he doesn't really fully grasp them, right? And I can't blame him. I also don't fully grasp, especially this part of physics. But still, it's kind of it seems to me like he doesn't understand it, so it must be wrong, really. So
The energy of the vacuum, dark energy as we call it, is the greatest mystery in all of creation.
I mean, the jury is out on what's the biggest one. It's certainly one of the bigger ones. For our current understanding of physics is.
Dark energy, a hypothetical form of energy that allows an accelerated expansion of the universe.
Nobody knows what the dark energy is. There are thousands of people out there trying to work out what the dark energy is.
I mean, that's not true. I wouldn't say thousands. It's more of a thing that like dark energy, as much as dark matter, is kind of necessary for our understanding of the cosmos. However, in contrast to dark matter, we have even less idea of what it could be and why it is there. The thing about dark energy really is it's not all too important. We just know that it has to be there, according to the way we understand it, that it has to be there, and we would kind of like to know the basic scale of it, really. It's not all too important to really figure out what it really is. It's just like with dark matter. Particle physicists would have you believe that it is a huge problem that we don't know what it is, when really it's not. Astronomers would just like to know the basic distribution of dark matter, and then we'd be happy. So, and again, dark energy as well as dark matter don't really influence our daily lives, right? They are only there on huge scales and at the very edges of our galaxies. And in the case of dark energy, those effects really only come in at ridiculously large scales, right? So it's not really all too interesting from a pure practical scientific standpoint. And it's also not really all too much important, I believe. I'd say that's completely the opinion of a to-be astronomer / to-be physicist. So, you know.
They do is they have to invent it now. And if you've ever read the science magazines, they say, well, there's dark energy.
You know, in German, we have a saying, and it's Schuster bleibt bei den Leisten, which essentially means the shoemaker should stay with making shoes. He shouldn't dabble in stuff that clearly goes beyond his understanding, as is the case for this gentleman. If he has ever so much as read and fully understood a single paper about cosmology that was published like in his lifetime, I'd be highly surprised.
And dark matter out there, and they constitute 96% of our universe. The reason they say that is because they need it. It's not going to work. Their Big Bang universe is not going to work without that matter and energy.
It's not necessarily that we need it. It's that our observations that we have would require something like that. So for example, we can observe that the universe is expanding, right? You know that. And the thing with the universe expanding is that we don't really know why, and so but we can clearly see that it is. So there has to be something there, or somehow all of those observations would be completely wrong. The obvious question there would be, how could like generations of observations about this, like it started with really gained prominence with Edwin Hubble's observations, right? So this is quite some years ago now. 3 generations of astronomers have made those observations with different kinds of measuring equipment, and have come to similar conclusions. Not quite the same, but you know, you always have a bit of a spread in measurements. That is natural, right? But like he pretends as if we made up a theory and then something huge doesn't fit it, and then we say, oh my god, no, we invented dark energy. No, that's not what it really is. The thing we did is we had an observation, and from the observation we concluded, well, things are moving away, and they're not only moving away, they're accelerating in moving away. So some energy, right, must be required for this acceleration to take place, right? Some kind of force, if you will, and as you may know, is that energy is force times some distance, right? Or like integral over force times distance. Force applied over a certain distance really is work, and work is just the difference in energy levels, and so on and so on. So there needs to be some sort of energy there. All of our observations are that's as simple as it is. There is no holy model the way he portrays it. I'm sure he thinks that there is one, but then again, it's not really important what he thinks, because I mean, again, he's a theologist. Also, I've read, interesting enough, he doesn't even have a doctorate. He said that he has a doctorate, but that was by a non-accredited university for some religious thingy. So, not, you know, saying anything, but, you know, that I find it to be curious. Let's continue. Also, I think it's super cool that he made a documentary in which he interviewed himself next to a whole bunch of somewhat accredited physicists to make him look like an expert. That's not like shady at all, but you know. This question is meaningless. What is significant? The question, if we are significant or not, is not a scientific one. This is very much a philosophical one, if you want. It bears no meanings to the realms of science whatsoever. Also, what is significant? When is something significant? Would you say that a single human is significant, or would you say that humanity as a whole is significant? And significant on what scales? Would you say that in all of the universe, humans are still significant? So, like, I mean, you can throw around words, right? But I'm not interested in that. I will skip this portion. But we are almost at the 15-minute mark, so I think I'm going to leave it there for episode 11. Thank you for watching, and leave a like, and maybe even do all of the other YouTube things that people do. And until part 12, thank you very much for watching, and goodbye.